To determine the CBR, first measure the load required to obtain a penetration of 2.5 millimetres. Similarly, record the load that achieved a penetration of 5 millimetres. Now the 2.5 millimetre result is divided by 13.2 kilonewtons, and the 5 millimetre result is divided by 19.8 kilonewtons. The larger of these two is calculated as a percentage, and this is reported as the CBR. So first you will have transcribed all your raw data into the Excel spreadsheet. All these cells are calculation cells. For these, it is best not to write any measurement values. Rather, the calculations are done by referencing the relevant cell addresses containing the raw data. So let's go to work. First, calculate the radius as half the diameter. Now to calculate the volume, it's pi times the radius squared times the height. And format this one down to a whole number, as 4 significant digits is plenty. For the corresponding moisture content, first to calculate the moisture content as the difference between the wet and dry sample masses. The dry sample mass is of course obtained by subtracting out the container mass. Finally, the moisture content, which is the moisture as a fraction of the dry sample mass. Note that this cell has been pre-formatted to show the result as a percentage. Now to determine the mass of the compacted sample, subtract out the mass of the mould from the mould plus sample mass. Wet density is then calculated as mass divided by volume of the sample. Now the dry density is obtained by correcting for moisture content. In this case it's 100 over 110 times the wet density. Finally, the CBR calculation. I'll first link the values for the 2.5 millimetres and 5 millimetres penetration loads. Now the CBR values are calculated as the load at 2.5 millimetres as a fraction of 13.2 kilonewtons, and similarly for 5 millimetres, the load as a fraction of 19.8 kilonewtons. Note that both these cells have been pre-formatted to display percentage. The final result is the larger of the two. Now to plot the data. I will place an XY scatter plot, straight lines with markers. So now with the frame for the plot in place, let's plot the relevant data series onto the chart. First for the gravel sample, the X variable is penetration in millimetres, and the Y variable is the load measured in kilonewtons. Now add a second series, the limestone sample. It's the same range of X values, and then the load at various depths in kilonewtons. Finally, to label the chart in full.